Today, Professor Dr. Manoj Kumar will talk on the improving the effectiveness of a warehousing operations, a case study. And this paper is published in the Industrial Management and Data System 198 by 899, page number 328, 329. This is a very beautiful case study of the warehousing operations. The general warehousing concept includes the storage and retrieval operations, the organization aspect, the mechanization equipment for material handling, media for the material storage, and the building itself, which is necessary to protect the goods environment. The task of distribution consists of moving goods from the production line to the customer in an acceptable time and doing it economically. However, there are an infinite number of the solutions. Optimum or near optimum solutions are difficult to find and often involve more than around running ingredients for the shortest path as well as the removal of the unnecessary waiting time. Inventory control, production control, and the warehouse management are the underlying methodology that affect the industrial success of distribution organization. Both the physical success of the material handling and stocking as well as the underlying methodology are commonly denoted by the word warehousing. Warehousing activities concern the physical storage and retrievals of the materials and also the processing of the information needed about the goods stored. For example, lot or the parcel has an origin, its supplier, an identification, its designation, a dimension, usually the quantity, a destination, and a customer. Basically, warehousing methodology is information oriented and requires the use of the efficient media to store and handle data about the movement of the goods. It is important to have good control over the inventory. Management should ensure that for each item, the correct stock level is available. On unnecessary money is tied up in inventory. The warehouse capacity is both economical and efficient. The goods are properly kept. To achieve this, a focus on the correct evaluation, identification, and classification and quantification, retrieval, and security of the goods would provide a clear and accurate view. Over the past 20 years, the automotive industry has been sinking deeper and deeper into recession. Owing to massive technological development, a worker of the 1990s can produce as much as 10 workers could in the 1960s. To remain at the forefront of the progress, competition is fierce and productivity and efficiency are nowadays the major focus of all development programs in the modern industry. For instance, it was proven that the internal combustion engine are highly pollutant. Some manufacturers had to act on this research and are continuously striving to reduce the environmental risk of their present products. Environmental concern is not a fashion or a passing fad. It has been established as a serious world issue in our society. Therefore, it is logical to expect that the motor industry will reduce 7 more in sizes to remain competitive in the global market. Companies endeavor to maximize both their productivity and their quality. Warehouse performance measure should be based on organizational strategy, objectives, and the competitive demands. Effective performance measurement system go beyond reporting history to improve future operations. The measurement system must be balanced between the internal and external perspective. A number of researchers and practitioners have studied warehousing operation from different perspectives such as receiving, storing, picking, packing, shipping operation. However, there have not been many articles that address the improvement of the warehousing operations in the real life situation. Also, consensual framework is lacking for improving the warehouse operation, take into account the concept of the just-in-time and total quality management together with the information technology. Realizing the importance of the warehousing operation in improving customer service level, an attempt has been made to study this subject with the help of a case study. Warehousing operation. Today's warehouses may function autonomously, but they must also learn to think universally. This can lead to the development of the advanced system built on the idea of distribution at an enterprise level, connecting multiple sites and supply chain together for the network-centric view. Storage is the core activity of the warehousing, and it identifies the location where the goods are deposited and held until they are demanded for usage. Since items are of many different shapes and sizes, there are also different usage rates. The storage space which poses different problems. For example, first in, first out storage or a stock or even a dedicated container are useful storage mechanisms. They must be designed to fit each item or category of items. Built-in flexibility can be an advantage for the continuous improvement of the inventory control. Online analytical processing and data analysis are the decision support technology used in the warehousing operation. The main objective of this technology is to enable the enterprises to gain competitive advantage by exploiting the ever-growing amount of data that are collected and stored in corporate databases and files for better and faster decision making. Typically, warehousing compromises six major throughput activity: receiving, transfer, handling, storage, picking, and expediting. Once the material are transferred to the storage area or when they are transferred to the expediting area, handling takes the parts into or from the location to minimize the time expected in the retrieving orders. It is suggested that items that have the highest turnover are located nearest to the shipping area. Slow moving items should be kept at the other end of the store, while expediting material, the preparation of all information document is connected. Where carriers are unloaded, items are sent to the packing before shipping. Final checks on the shipping invoice and the possible damage are made. Packing is an important element of the dispatch function, although it is not directly connected with the warehouse operation. It usually finds its place within the same building. The warehouse must assume the responsibility of the linking containers, which would improve the cost effectiveness of the transportation, facilitate the mechanization of the warehouse, reduce the amount of the packaging material used, and saving an expensive recycling spend. Enger and Ender have pointed out in their paper that the young world, a rapidly growing retailer of the children's apparel and the furniture, eliminated their warehouse bottlenecks by replacing the redundant paper-intensive manual operations with an automated warehouse system. With automation and the barcoding technology, Young World reduced labor by half and saved 20% on warehouse overheads with a payback time of slightly over 2 years. Improvement of the warehouse operations can be realized using software and automatic data collection. In particular, barcodes in conjunction with the software can be used to provide a better view of the warehouse operation by collecting accurate data on the space utilization, return on investment, material handling equipment use, labor cost, order picking, and the customer service. Software is an important control and scheduling tool suited for the enhancement of the warehouse operation. Although software may not help much when the material handling equipment is insufficient for the risk, considering it seriously is important step to better handling of the goods. keeping track of the inventory and serving the customers. Order picking in conventional warehouse environments involve the determining a sequence in which to visit the unique location where each part of the order is stored, and thus is often modeled as a traveling salesperson problem with the computer tracking of the inventory parts. This is the activity in the warehousing operations: receiving, transfer, handling, storage, handling, transfer, packing, and expediting. Now we stored in the multiple locations, simplifying replacement of the inventory and eliminating the need of the reverse space or for the each item. Warehouse layouts are the perfect examples of the fundamentals of neglected. Most organizations simply treat the warehouse as a place where product is stored until it needs to be shipped to the customer. This often results in the shutdown of the warehouses. Susskind examined a company whose only warehouse facility was nearly shut down. He emphasized the approach used by the company to meet its peak inventory storage and the shipping requirement. A properly installed warehouse management system can revolutionize the way a company does business. Any change in WMS should be properly communicated and coordinated throughout the organization in the advance. A conceptual model to improve the effectiveness of the warehousing operations. In order to present a framework for improving the effectiveness of the warehousing operation, a conceptual model has been developed as shown in figure 2. The issues of improving warehousing operations are discussed under two perspectives, JIT and TQM. The JIT application in warehousing operation is concerned with the demand pull, minimal economic quantity, reduced work in process, supplier reliability. Preventive maintenance and eliminate buffers. The issue related to the TQM are a long-term commitment, war on waste, continuous improvement, total quality control, continuous training, and ergonomics. JIT helps in scheduling the operation, reducing the lead times, inventory throughput time, and improves on-time delivery of the goods to different destinations. TQM helps to improve the effectiveness and quality control in warehousing operation. Further details of improving warehousing operation are discussed later. JIT application in the warehousing operation. JIT is a philosophy which aims to bring certainty and smoothness to the flow of the material through the supply chain while reducing the work in process inventory, enabling the lowering the stock and thus reducing the lead time. For many buying companies, JIT forces the supplier to carry stock in order to ensure timely delivery. In fact, this could be described as a transfer of the inventory to another location within the supply chain. The proper approach implies more cooperation to ensure success. JIT is the application of an extremely oriented approach to the scheduling, but its implementation also has an impact of the inventory management and other areas. JIT emphasizes improving the manufacturing efficiency as an operating system to solve the productivity problems. JIT aims to reduce the inventory and throughput time, thus decreasing the number of parts waiting. The new system has to be ergonomic or user-friendly and approved by all the staff. Thus, operational analysis emphasizes the role of the unnecessary. Figure 2, a conceptual model for improving the efficiency of the warehousing operations are the given here. Improving the warehousing operation, reduction in the lead time, inventory and throughput time, on-time delivery, improved effectiveness and improved quality. JIT is the demand pull, minimal economic quantity, reduced WIP, supplier reliability, preventive maintenance, and eliminate buffers. TQM, long-term commitment is there, where on the fast is there, continuous improvement is there, TQC there, continuous training, ergonomics is there. This is the conceptual model for improving the warehouses. Workload and aims to bring the information flow in the line with the physical flow in order to optimize the overall process time. Comier and Kersey present a case study. to outline some analysis and design principles for a central distribution facility in the warehousing operation to support a GIT operating philosophy. They have presented various facets of the study, such as the determination of the storage and throughput requirement, a conceptual warehouse layout, and an economic analysis. GIT is a demand pull system. Manufacturing planning begins with the small stage, last assembly line, or works backwards through the every manufacturing process, and also to the vendors and the subcontractors supplying material and component. GIT and the purchasing work effectively if pull parts arrive at the right time, in the right place, and in the right quantity are the most importantly. If the parts that arrive are the usable. The GIT approach contracts markedly and the warehousing operation system depending on the substantial inventory. It brings exactly what a customer wants, where and when he decides. Therefore, the queuing time of the batches is minimal, WPIP low, throughput timing and the space requirement in the warehouse are reduced, and the flows of becoming virtually continuous. There is also an absence of the buffer and safety measures which normally slow down the process. Efficient warehousing management can bring about the valuable developments and the philosophy. For example, GIT can further contribute to the improvement in the performance of the production activity. In particular, it affects the supply chain if functioning as intended. It can eliminate factors considered superfluous or excessing, such as a non-value adding activity. It may also enable the lowering of the work in process inventory, therefore reducing lead time. Ideally, GIT aim to ensure constantly punctual delivery of high quality goods at the optimal cost. The industry that are currently having the most success in terms of the realizing these goals are those striving to meet the international competition. To beat high holding costs, they cut purchase and production lot sizes and dodge buffer stocks. GIT operating system in the warehouse must wait for the customer to decide where and when to deliver what. A customer triggers activity throughout the operating system. The order flows back, triggering each stage of the overall process at the proper date. The rapid movement between the processes is an essential prerequisite. The time-based dimension of a product are becoming an increasingly important component in assigning strategic advantage. While traditional long lead times and high inventory levels are increasingly less important. However, GIT hinges on the realization of the flow and aims to reduce the intrinsic waste in the process of the warehousing operation. Major elements of the GIT are embedded in a more comprehensive TQM system. GIT emphasizes the importance of the improving manufacturing efficiently as an operating system to solve productive problems, while TQM aims to improve the overall effectiveness of the organization through the expensive attention to the social aspect of the management. Fuller suggests that the implementation of the TQM, group technology, GIT, MRP, IT, and lean production will benefit warehousing operations. The material flow follows the information flow. If there is any gap between them, it will lead to the congestion and poor customer service level. On behalf of a close communication, the responsiveness can be maximized, eliminating the needs for the safety of stock. As advised by the Department of Trade and Industry in the UK, the following are implications of GIT in the warehousing operation. GIT hinges on planning and certainty. Need for enhanced sales forecast. GIT can only work where there is a cooperation and trust and need for a strong supplier-customer links. GIT will break down without proper communication, need for effective information system. Awarding supplier long-term contract, which gives them the confidence to invest in meeting their future requirements. Working towards zero defect through a quality assurance program and removing non-value adding activity along the whole supply chain. TQM application in the warehousing operation TQM is a management approach to the organization centered on quality based on the participation of its member and aiming at the long-term success through the customer satisfaction and benefit to the members of the organization and to society. Since the introduction of a quality approach in the manufacturing, it has left its mark on the landscape of the manufacturing industry. The quality and high performance of a company depend on the criteria listed in the following four subsections. Long-term commitment. To achieve a long-term commitment, one must know the behavior of the product and its process for the whole of its life cycle. Factories, machines, and the material must be economically sound and environmentally friendly. Plan for the long term rather than the short term. Short term issue are the firefighting should remain the task of the local management. Locally, if authority is increased, where the problems in the warehousing operations occur, this will increase the ability to solve minor problems, provided that the staff are fully trained. This should also release time to concentrate on problems at a higher level in the warehousing operation. The use of Pareto analysis on each quantifiable problem help to resolve them effectively. War on the waste. Generation of waste in the warehousing operation implies two costs. The value added, which is lost, the cost of the disposal, which is ever increasing. Apply the supply chain a strict inspection would prevent the process of transporting waste, as once the item is defective, it can only end up as a scrap. To generate scrap is also to order things which will remain unused in a store until they go or to dump. One more cost occur in this case, the space occupied in the warehouse. According to Burton, it is always cheaper to do the job right first time. TQN. TQC aims to prevent waste by the not producing defective products in the first place. It emphasizes that everything is important for the goal of the achieving first class quality. The relationship between the suppliers and the buyer leading ultimately to the customer must be integrated to prevent the poor quality rather than trying to detect what is not to a specification. TQC is the process of setting standards acceptably for the goods of the purchase in the warehousing operation. A specification is a detailed description of any given thing. Once the specification has been drawn up, all the goods supplied to the store warehouses must meet the requirements to be rejected. Continuous training. One of the main strengths which people have is their flexibility. They will be as flexible as their knowledge allows. The teamwork allows the sharing of the skills and know-how among the groups in the warehousing operation. Therefore, the knowledge of the team reflects to a large extent the knowledge of each member. It requires that each member perform his/her task to best of his/her ability, while also being able to help his/her following team members in the warehousing. Often, specialists are required and they must have the broadest possible knowledge of the warehousing operation. A case study, Lucas Action, England. An attempt has been made to study the application of the model in a real-life situation. This section deals with the Lucas warehousing operating system, principally the goods inwards. It especially highlights the shortcomings of the system. For example, the time spent walking between the work area and the GI office to process delivery, and also the massive amount of the paperwork involved, which is costly and time consuming. Warehouse activity often require the processing of a vast amount of the information. If there is not an adequate level of the structural and operational effectiveness, this data handling may become an instrumental task. Using the philosophy of JIT, it will be seen that several improvements could be made. For example, JIT would ensure a smooth, reliable material flow, thus eliminating buffers, reducing WIP, stock levels, and the lead time. JIT aims to bring smoothness and certainty to the material flow. That this technique helps to reduce the throughput time of a process, and therefore the number of parts waiting before the processing is reduced. The principle of the TQM should make the GI procedure more ergonomics, removing unnecessary workload, and optimizing the overall process time. Background of the company: to study the application of the model in the GIE operation system. Lucas Electrical heavy duty product situated in Acton, UK was selected. Lucas is a small medium-sized enterprise SME with a workforce of the 500 and an annual turnover rate of the 30 million. Lucas is a manufacturing company that produces starter motor alternators and electrical motors for the electrical rotating heavy machines. The products are manufactured to stock. It is a high volume and the low variety production system. The system, including warehousing, follows a push type scheduling system. The decision making in the Lucas follows the top down approach. Acton gate 4 is in the main door through which any material goes into and out from the Lucas plant. The transfer action moves the goods from the reception to storage and from tire retrieval to delivery at a point where the expediting process starts. Activities such as loading, positioning, and unloading are assisted by the transfer devices. These transfer devices can be very costly and represent a large investment. Their solution must be cost effective and not hazardous. Forklift. Over the past 10 years, Lucas heavy duty products has gone through the dramatic changes which have significantly affected the size and the structure of the organization. A vertical functionally integrated structure was turned into a vertically disintegrated process-oriented organization. The UK-based market expanded to an international supply chain where suppliers and the customers can be based in Europe, Turkey, or India. Furthermore, only the key activities were kept in-house while external supplier proved to be more effective in the execution of the process work and the manufacture of the small standard items. The amount of the delivery increased and become more urgent than ever. Therefore, nowadays, the floor at the GI area is covered by the parcels waiting to be booked in, then collected by the material controller to go to the production or the assembly lines. Research methodology. For the case study, the data on the warehousing operation were collected through the interview with the key personnel of the Lucas Heavy Electricals. Based on the literature, a conceptual model for the improving the effectiveness of the warehousing operation was developed and reported in the previous section. A case study research methodology was used to study the application of the model. The main objective of the case study is to test our conceptual model for the warehousing operation in a section, as GI section of the company. The data were collected through the interview and from company record. The present warehousing operation system of the company includes many non-value adding activity. From the case experiences, a new warehousing operation system for the GI section of the company was proposed. Goods inward operating system. The function of the operating system is to use and convert physical resources into the output. Basically, there are three categories of the physical resources: materials, machines, and labor. Materials are the physical items consumed and converted by the process. Machines are the physical items used by the system. Labor provides and contributes to the operations of the system. Functionally, there are four categories of the operating system, such as manufacturer, transport, supply, and the service. The principal characteristics of the manufacturer: that something is physically created. Transport moves things from the place. Supply is primarily function of change in possession of utility for a resource. The treatment of the accommodation of something or someone is provided through the function of the service. These four principal functions can together describe every operating system and their subsystem. Any complex organization can be described using one or all of these functions. Further consideration of parts or a subsystem of the whole will allow a more accurate description. The warehouses and therefore GI can be described as a supply operating system. The goods come in from suppliers and remain unchanged. The core function of the GI is to upgrade the inventory on the information system and to make each component available for collection to the next stage. The components are taken out of their parcel and uploaded into a container designed to their use on the production line. And the computer system database is updated regarding the goods inwards. Customer, the aim of the operation is primarily to provide the modules reliably with the goods from external supply. The basis is to maintain the schedule so the Lucas customer can receive their deliveries on time. One major problem is that, for example, a single missing washer can delay a whole assembly line and alarmingly reduce its output. This is due to the lack of the organization or mismanagement of time. Time is resource which, whether used or not, is the continuously passing. Time can be converted into cost in terms of the usage of resources in a certain duration or in terms of the cost incurred while not running, hence being one useless overhead. The production and assembly lines cannot work effectively in JIT, having long lead times owing to the supply unreliability. Parts from the truck to modulate may wait for as long 2 to 5 days or only for the 15 minutes if they are needed very urgently. Some suppliers are called approved, others are called designated. Goods from the designated supplier go to inspection at the vendor quality section before being made available to the module, as sometimes even suppliers are unsure of what they have sent out. This is a basic requirement of the ISO 9000 standard. Both the approved and designated supplier parts must wait 1 or 2 days of the data is securely entered. Once ready, that the trays go into the storage racks where they wait to be collected by the modules. Sometime, although the parcel is on the premises, it is possible that it has not been booked in, but the information still has to be updated. Consequently, because of the delay on the day parcel, a whole module may have to be stopped, and so it becomes a priority. Therefore, some experience of the stores is helpful in recognizing in advance when situations might occur. Information: the advice notes are checked and stamped as each parcel is opened. They are grouped and sent to the GI office where the GI notes are raised. Primarily, the GI notes are useful to the purchasing department. They allow the stock on the hand to be kept as to date so that the inventory control is the more accurate and efficient. A green GI notes tells the material controllers in the modules where to find the goods they were waiting for, as shown in figure 3. If during booking the material and the information were to be processed in one sequence of action, then this new sequence would group the work area and the GI office. The parts wait on the trolley or in a corner until the GI notes are placed into the correct container. This is because the information flow is separated from its real path by bringing it closer to the unpacking operation. The information will flow and thus would suppress two buffers, since the information mainly concerns the material itself. The storekeeper and a GI note which holds the name designation, the quantity of the lot, supplier information, and the destination. Copics manages the inventory and includes an MRP software. The accounts department uses the information for the GI note. When an invoice comes from the supplier, the accountant matches it with the GI note on the screen before paying for the goods, and then the money is sent by the due date. If for some reason the invoice does not match with the information on the screen, the advice note transported with the goods is taken out of a fleet as an additional checking process. The quality of available information is crucial in defining the accuracy of the long-term forecast. In this instance, IT is invaluable. It can handle, store, and manage an amount of information what would confuse any store manager. What is more value adding to the read the information in an understandable way or to handle it. IT provides access to more knowledge, more measure and statistics. This also results in a tremendous saving on the research, time and money. Analysis of activity in the project warehousing operation. GI operation can be grouped into 4 main actions. The storekeeper receives the parcel in the work area. The data are entered on the screen in the GI office. Dangerous supply is inspected at the vendor quality. The parts are kept in the storage area until they are required in the modules. The GI procedure detailed in the table 1. Present system of the warehousing operation. The principal function of GI is to book in the components from external supply. The storekeeper perhaps them for the module and also updates the information system. The data are then available to the rest of the factory owing to the shared printing facility. The components are handled in a work area where information is treated elsewhere. In the GI office, long walks are necessary to reach the storage area of the office. Subsequently, these are the good inward information flow. The diagram is shown here. Supplier is here. Carrier shipment note is there. Carrier consignment duplicate is there. Discard is here. Sign is here. Advice note is there. Copy system is there. Stock and hand there. Rise of GI notes is there. Advice note is there. Account is there. BQ storage is there. Blue GI note is there. Green GI note is there. Blue GI note is there. Storage racks are there. Blue GI note is there. Modules is there. Jobs are carried out in batches. Furthermore, the actual waste for the printer is the first 2 pages and the first 2 copies of the each printed page. Each from is worth for the 4 fans. The actual procedure comprises short sequence of the operation with a buffer in between. The delivery occurs while quite irregularly, hence the throughput time from the gate 4 to the module is difficult to predict. All idle periods considered a non-value adding activity. Expand this duration, the randomness generates queuing times between each sequence up to half a way. Paperwork, the blue GI note exists to travel with the goods. No job must ever be without identification. Each incoming parcel has an attached advice note. One advice note can have many lines. Each line calls a job and therefore one GI note. When the parts go into the trays, a SIP 150 card is added and advice notes go to the office. The separation of the advice note from the good implies a means of identification of the lot. The GI process note SIP 150 holds the main information and remains with the good. The blue GI note is also added to the tray. The green GI note tells the material control about the goods availability. The C150 card holds the same data as the GI note and the advice note. The GI note may be raised in the same place of the C50 card. It is possible that another procedure may result in the same output when the advice note is taken out of the parcel. The storekeeper raises the GI notes for the each job so that the container and the goods are identified as early as possible. To achieve this, a screen and printer should be located next to the unpacking area. Thus, the information and the material are processed in the same sequence. Such a change may require the form used for the GI note to be modified. The computer can be used as a tool for work enhancement through an internal email system. A list of the goods ready in the store and their location will make the green GI. Not redundant. Errors on the paperwork, active notes, or on the screen constitute query. This is a problem external to the GI. Nevertheless, it hinders the whole operation. Generally, a mistake in the acquisition of the order on the computer or a misprint on the paper can mean the storekeeper trying to resolve the problem for up to half an hour. A double check on the information sent out of the department, allowing the storekeeper to do some corrections, would significantly reduce the time spent on the query. There are many hindrances in the present GI system of the warehousing operation, which cause delay and hence increase the number of non-value adding activity. These are the activity in the current warehousing operation. Activity type: move, operation, waiting, move, operation, operation, decision, operation, operation, move, operation, operation, waiting, move, move, waiting, operation. These are the description is given. There is the activity number is given. Activity type is given. Description is given. There are the 43 activity in the current warehousing operations is given in the company. Factors which affect the GI system of the warehousing operation are the as follows. Long lead time because of the delay which arise from the many handoffs, proper warehouse layout, limited printing facility, poor format of the information about the list to waste paper on the printer. There are many activity in the GI system which increase the number of the buffers and hence the inventory buildup, irregular delivery owing to the poor communication in the GI system. Increase in the queuing time of the goods because of the above reasons, high level of error in the forecasting of the demand. Unnecessary queries such as the errors on the advice note on the order and misprint on the paper that increase non-conjugation on the warehousing operations. Purpose system of the warehousing operation, GI operation improvements lie in the way of the information is handled. The area which appear to have the highest potential for the improvement are electrical supply area and inland goods. The changes would not be modify the book in procedure insofar as they have only require a broader understanding of why they will have to handle parts as much as their respective information. Basically, the unpacking and the transport of the physical items are considered to be the core activity of the GI. Whereas the other activity could be seen as a polluting, non-value adding activity. Information is actually processed centrally in the GI office. The removal of the GI office will thus affect every sub-area in the GI department. Each sub-area may require a specific analysis to define actively how, where to handle the parts with their information. On the two stations, one can be made available on a part-time basis to raise the GI notes for the other sub-areas until the change takes place in the whole department. The proposed processes for warehousing operation are detailed in the table 2. Implication of the proposed warehouse operation system. The implementation of the new layout involves change in the whole structure of the GI operating system. Therefore, it needs to follow certain steps which include change the layout for the electrical supply, develop suitable performance measure, review the new layout within the scope of the department, employ large containers, recycling of the raw materials, certified suppliers with a small and medium size delivery, and 5 continuous improvement. Once the parts are in a tray with their correct GI note, they can be placed in a storage racks. The distance between this area and the working area justifies the use of the trolley to base this operation. Primarily, the actual base size is defined by the capacity of the trolley. It appears to be satisfactory. A further study may be useful to determine the optimal size of the trolley. Nevertheless, the behavior of this new system must be measured so that every parameter is under control. A gravity conveyor placed at the center of the room will handle the incoming parcel. 2 workstations at each side will be equipped with a terminal to raise the GI notes. A printer can be shared among the 2 operators. The printer must be able to produce each from economically as the activity takes place at the center of the room. The storage racks can be arranged around the room. They should be recorded according to the destination of the goods store. Then buffer stores may be set aside for the query where parcels can wait while a query is solved without delaying the subsequent jobs. Comparison of the present and proposed system of the warehousing operation. Comparison of the present and proposed system of the warehousing operation was carried out to determine the number of the value adding and non-value activity in the GI operating system. In the proposed system of the warehousing operation, the total number of activities reduced from 43 to 30 activities. Also, the number of the value adding activity have been increased by 7.4%, and the same time the number of the non-value activity has been decreased by the same ratio in the proposed system of the GI operation. JIT and TQM strategy method help to improve the information flow, hence the flow of the material through the supply chain, which leads to the reduction in the number of non-value adding activity, hence the lead time. For example, JIT requires having only the necessary stock to meet the demand, and therefore it reduces inventory level and associated cost, which in turn improves the working environment. Implementation of the GIT simplifies the information system and its application, leading to the improved communication between suppliers and the customers. 2QM leads to the improved understanding of the warehousing operation and their businesses objective by the employee. This would lead to teamwork and cooperating support work. IT facilitates better communication and the supplier, leading to the improved delivery performance and reduction in inventory cost. All of these have aimed to reduce the number of the non-bowling AD activity in the GI system. The percentage of activity with present and proposed system of the GI warehousing operation is shown in table 3. Summary of the finding and recommendation. Presented here are some of the findings and recommendations on the reduction of the throughput time in the warehousing operation. The processing of the information plays a vital role in the warehousing activity. Each individual batch has its own specific details, such as its origin, supplier and identification, and its final destination. It is therefore clear that an efficient and reliable data handling system is needed to store accurately the extensive amount of the information on goods and their movements. There are obvious benefits that warehousing can bring, provided that the warehouse is run competently. That is, the stock for each item is at the correct level. The warehouse capacity fits its purpose, and the goods are appropriately stored. The general level of organization in terms of distribution will ensure effectiveness, promote customer satisfaction, and could potentially facilitate profit building opportunity. There are, however, some sacrifices to be made when using JIT. In Japan, for example, companies have close control over their suppliers and demand more frequent delivery. This in turn requires a greater level of the transportation and therefore creates more traffic, which is already a problem in the Japanese city. A further problem with JIT may rise when an item inventory is cut to zero. As a company has no safety stock, this will have serious implications for the company if there is suddenly a surge in the demand. To prevent such a situation, the inventory level of an item would be pegged at a point between JIT delivery and holding of stock. The principal component of the behind JIT philosophy involves solving productive problems by improving manufacturing effects efficiently. It can be argued that these together the other important elements of the JIT from part of a 2QM attitude, which in the wider sense aims to improve a company's general effectiveness by the working to advance the social aspect of the management. More precisely, this would require the active participation of all the management members working towards customer satisfaction and benefits for both the organization and society in general. Proposed activity for the warehousing operation are given here. There are the 30 activity which are given here. After the analysis of the GI procedure, it appears the information handling, supposedly a core activity, is separated from the physical flow of the material. This means that the one activity waits for the other, and hereby buffers delay are generated, hence to reduce the lead time and thus throughput time. A greater emphasis should be placed on the information flow. The GI operating system requires some structure changes, such as the introduction of an individual screen and printer for each operator. The program described in the post-day main section aims to provide guidelines for the implementation of an efficient data collection system for goods from the external supply. The level of technology and effect which is independent of the efficiency intrinsic to the operating system. Barcoding and EDI would prove useful, but would require some supporting structure before being implemented. The state of the implementation system in the warehouse does not allow such improvement. However, it is important to provide operational efficiency before moving towards advanced technology. EDI may be the next logical step for the further future improvement. There is a lack of the software package to cover the application area in the manufacturing or distribution company. Enterprise resource planning software packages can be expanded to handle the multi-stock room, warehouse operation, multi-company operation, and multi-currency application. Prospective ERP system buyers need to be forewarned that the performance, quality, and cost of the various packages with the performance claim in the different areas vary greatly. Conclusions are there. An attempt has been made in the paper to study the effectiveness of the warehousing operation, its requirement, and the benefits it may bring. A conceptual model has been developed to improve the effectiveness of the warehousing operation. Also, a case study has been conducted for the goods inwards operation in one of the section of the warehousing operation in Lucas at Acton, UK. Finally, the summary of the finding and the recommendation from the case study are presented in this paper. This paper stresses the importance of the efficient warehouse management since the activity performed in a warehouse management environment have a direct influence on the overall effectiveness of a company and its customer service level and are therefore factor affecting profit. It is essential to ensure that there is a sound warehousing methodology in operation whereby the distribution of goods from the production line to the customer takes economically and punctually using a shortest path philosophy and avoiding unnecessary waiting time. In addition to this, the following may improve the warehousing efficiency. Moving to make order system, pool production system, electronic data intelligence, eliminating incoming goods inspection to the minimum level, improved accuracy for the forecasting, minimum personnel in the GI system. The references are given of the paper is given here.